Functional ideas are arising in C# as well as in other mainstream languages, and functional languages are becoming an alternative for real-world projects. Also, Microsoft recently introduced a new language called F#, which has a strong background in traditional functional languages, but as a .NET language also benefits from the rich .NET and Visual Studio ecosystem. The elements of functional style. Nine reasons to use F#. Units of measure. Functional programming with .NET, explorative programming with the reckless synchronous and parallel programming. Embedded domain-specific languages, EDSLs. Scripting, a practical language for academia. Expand your mind and career. And it is fun. What areas of code are you using F# for? Algorithmic processing, including calculations, DSL creation, concurrent processing, immutable data, message queuing, asynchronous workflows, so on, parallel execution, long-running processes, scientific works. Parallel programming, language-oriented programming, for example DSLs. Data-intensive analysis. Here are some of the F# examples. Programming concepts. An interesting bit of F# behavior. Let us have a closer look at how F# and C# is used in practical.
So let's start by looking at some of the basic functional concepts, and I will use C# to explain some of them, and later we will look how the code would actually look in F#. The interesting point here is that functional programming is a general programming paradigm that you can use in any programming language. So just like you can write object-oriented code in C, you can also use functional ideas when writing code in C# or even C++. So I will use some familiar C# code to explain some basic functional concepts, and then we will look how to do the same thing in F#. So I already have some code here, which is just a very simple imperative kind of program that creates a local variable that represents random number generator, and then creates a variable num, and then 2 times modifies the value of the variable, and then prints the result. So as you can see, if we run it, it generates 2 random numbers and adds them. In imperative kind of programming, we are working with some state of variables, and we are modifying the value of these variables. On the other hand, in the functional style, we are describing the program not as a sequence of statements that modify some state, but rather as an evaluation of some expression or of some mathematical function. In this sense, we don't have any variables, we don't usually modify any values. So how can we write the same thing in the functional fashion? Instead of modifying the value of a variable, we can declare a new variable to hold the new number. So I can write something like this, and I'll have to change the names of the variables to make it legal C# code. And now, as you can see, we did a very small change, but now the code looks almost like functional code because we are not modifying any value of a variable. We're just declaring a new variable each time we need to calculate the new value. And if I run the code, you can see that it still works and it does exactly the same thing, but the code is written slightly differently. So I'm pretty sure you can now imagine how we could transform some pretty simple imperative code into a functional version. So let's look at some more interesting examples. I have a method here which is called SumNumbers, which takes two numbers as arguments and sums all numbers in the specified range. So let me just change the code here to call the function, and we'll add numbers from 1 to 5. And if I run the code, you can see that the result is 15. So the interesting thing about this function is that it contains a loop, and in this case it's much harder to see how we can represent the same idea without modifying any global state. So the loop currently runs, and during each iteration it increments the value of the local variable that counts the result. So in this situation, we'll have to change the code a little bit more. If we want to sum numbers in some specified range, we can also write it as take the first number and add it to the sum of numbers from the first number incremented by 1 to the last number of the range. We will also need to write a condition here, because when the first number of the range is more than the last number, then we'll have to return 0. That's an empty range. But otherwise, we can use recursion here to sum numbers from some smaller range and add it to the first number. So if we run the code now, you can see it returns exactly the same result, but it's now written in a different style, and as you can see, we are not modifying any variables here, and the code is also written in a more declarative fashion, because we are much closer to the mathematical description of what does it mean to sum numbers in some range, and we are not describing how to get the result step by step. So let's imagine that we would want to multiply all the numbers in the specified range as well. I'll start by copying the function and making some changes there, and then we will look at a better way of doing the same thing. So I'll also change the call here so that we call the mulNumbers function. And we'll also need to do a couple of changes in the function itself. We'll start by changing the initial value to 1, because otherwise we would multiply any number by 0, and we will use multiplication instead of addition. So now if we run the code, we can see that it printed sum of all the numbers in that range and also the multiple of all the numbers. Now the interesting thing is that the structure of these two functions is very similar, and if we have two methods with the same structure, then it seems like a very good idea to turn them only into one method that would take the necessary differences between the behavior as an argument. So we'll write a more generally useful function called aggregate numbers, and we'll change the calls here and also the recursive call. Now we'll need to give it a couple of additional parameters, and the first parameter will be obviously the initial value, which we will use here instead of 0 or 1. And in the first case, where we want to sum the numbers, we will use 0 as the initial value, and in the second case we will use 1. And we'll also have to propagate the argument in the recursive call. So let me just fix the typo here. And the second parameter that we will give to the function, that will have to specify whether we want to use plus